Simulations show that the mysterious Planet 9, or Planet X-Nibiru, may actually be out there. A new study suggests Planet 9 may be an Earth-sized world hiding in the distant reaches of our solar system. A fresh perspective on the elusive Planet 9, or what we would call Planet X-Nibiru, has emerged, suggesting that this mysterious object might be smaller and more Earth-like than previously imaged. A recent study based on computer simulations presents a new take on the hidden planet lurking in the outer reaches of our solar system. We've already been told by NASA a couple of years back. A NASA spokeswoman announced that there is a brown dwarf star at the edge of our solar system. Now, researchers Patrick Sofia Likauka of Kindai University and Takashi Ito of the National Astronautical Observatory of Japan delved into the behavior of distant Kuiper Belt objects. Through extensive simulations, they found that an undiscovered planet, once slightly larger than our Earth, could explain the peculiar orbits of these frozen celestial bodies. Their findings, published in the Astrophysical Journal, suggest that this planet might be orbiting at a staggering distance, somewhere between 250 and 500 times farther from the Sun than our Earth. Our Earth is 93 million miles from the Sun. That's 1 AU. So could Planet 9 be a remnant of early solar system formation? The idea that an Earth-sized planet exists in the far reaches of the solar system raises questions about its origins. Some researchers speculate that this hypothetical planet could be a remnant from the early days of planetary formation, perhaps a planetary embryo that was ejected from the inner solar system due to the gravitational interactions with Jupiter or Saturn. If this is the case, Planet 9 might be composed of similar materials to Earth, containing a rocky core and possibly even a thin atmosphere. Other theories suggest that the planet could have formed directly in the outer solar system, where conditions were vastly different from those in the inner regions. Unlike the gas giants, which accumulated thick atmospheres of hydrogen and helium, a smaller, more terrestrial world in this distant region might have retained a solid, icy composition. If such a planet exists, studying its properties would reveal new insights into planetary formation and migration models. The role of giant planets in planetary ejection. Planetary scientists have long theorized that the early solar system was a chaotic place, with newly formed planets shifting positions due to gravitational interactions. This period, known as the NICE model, suggests that the migration of Jupiter and Saturn led to the scattering of smaller planetary bodies. Some of these bodies were ejected into the interstellar space, while others may have been thrown into distant orbits, forming populations such as the Kuiper Belt and Oort cloud. If Planet 9 is indeed an Earth-sized world residing in the outer solar system, it may have been caught in this gravitational turmoil and flung outwards rather than being ejected completely. Its current orbit would be highly elliptical, meaning it could spend millions of years in the darkest regions of the solar system before making a closer approach to our Sun. And the possible connections to other hypothetical planets. Likauka and Ito study is not the only one to propose the existence of an additional planet in the solar system. In the past, other researchers have suggested that multiple planets beyond Neptune could exist, each contributing to the gravitational shaping of the Kuiper Belt. For instance, a 2022 study led by Brett Gladman and Catherine Volk hypothesized that there might be more than one undiscovered planet influencing trans-Neptunian objects, TNOs. The research published in the Astronomical Journal indicated that the peculiar orbital behaviors of trans-Neptunian objects could not be explained by a single distant planet alone. Instead, they proposed that a combination of smaller planets, perhaps similar in size to Mars or Earth, could be working together to produce the observed gravitational effects. Other studies have suggested that a planet the size of Mars or even a super-Earth could be hiding in the Oort cloud, the vast icy region that lies beyond the Kuiper Belt, and if true, the existence of multiple hidden worlds would radically reshape our understanding of our solar system's architecture. The challenges in detecting Planet 9, Planet X-Nibiru. One of the main difficulties in proving the existence of Planet 9 is the sheer distance at which it is believed to reside. At 250 to 500 times the distance of Earth from the Sun, this world would receive only a tiny fraction of sunlight that reaches our planet, making it incredibly faint and difficult to detect with traditional telescopes. Another challenge is the uncertainty of its orbit. Unlike the planets we know, which follow relatively stable and predictable paths around the Sun, Planet 9's hypothetical orbit is believed to be highly elongated. This means that it could spend long periods hidden in the outermost parts of the solar system before coming slightly closer, where it might be easier to observe. To overcome these obstacles, astronomers are turning to powerful new telescopes such as the Vera Rubin Observatory, set to begin operating in the coming years. This observatory will be capable of scanning the night sky with unprecedented sensitivity, potentially identifying distant, slow-moving objects that match the characteristics of a hidden planet. And additionally, infrared telescopes such as James Webb Telescope could play a crucial role in the detecting of the heat signature of a distant planet. Even though Planet 9 is expected to be extremely cold, it may still emit faint heat in the infrared spectrum, allowing telescopes to spot it despite its extreme distance. The implications of discovering an Earth-sized planet in the outer solar system. If Planet 9 is confirmed, it would have profound implications of our understanding of planetary science, of course. It would demonstrate that planets can exist in stable orbits far beyond the traditional planetary boundaries of our solar system, challenging our current models of planetary formation and migration. The discovery of an Earth-sized planet in such a remote region could also prompt new investigations into the possibility of habitability in extreme environments. While conditions on this planet would likely be far too cold to support liquid water, the presence of an atmosphere or subsurface heating could raise questions about whether such a world might have once been more hospitable. And additionally, a confirmed detection would offer valuable data on how common Earth-like planets are in the universe. If a terrestrial planet can exist in the outskirts of our own solar system, it might suggest that similar rogue or distant planets are widespread in other star systems, opening up new avenues for exoplanet research. Now, the idea that Planet 9 could be a lost Earth-sized world is an exciting and compelling possibility. As new observational techniques continue to advance, the coming years may bring the long-awaited evidence needed to confirm or refute its existence. Whether it turns out to be a rocky planet, an ice giant, or something even more unexpected, discovering such a world would fundamentally alter our perception of the solar system's outer regions, and until then, the mystery of Planet 9 remains one of the most intriguing unsolved questions in modern astronomy. And this is by Joseph D. from Free Jupiter on Collective Spark. Please leave your comments and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.